All right. So with inequalities, again, let's just go back to what we're doing a week ago, week and a half ago, whenever it was we were doing this. That remember a couple of different things they may ask you for if you're going to graph these. That if you have less than or greater than, if you're actually graphing these, that's an open circle. If you have less than equal to or greater than equal to, that's going to be a solid circle. But then working on interval notation just a little bit more, that if we talk about interval notation with these, remember that if you're doing these, you're going to be using parentheses. And where you had your solid circles here or your bars underneath it here for this one, this would be where you would use your square brackets. So we're going to kind of put all the pieces together for this one, that we're going to solve some inequalities, graph it, and write it in interval notation so we can kind of go back and do that. So we're solving equations, but now we're throwing in the inequalities. We're still going to graph it. We're going to do some interval notation. So we're still kind of practicing on all those things that we were doing, from last week with everything that was kind of going on there. So we're going to solve it. We're going to graph it, and then we're going to write the answer in interval notation. All right. And again, the big thing is that when you're doing these, that if we're solving these and graphing these, if you put X first, it makes everything a little easier because of how the line's set up and everything that goes on with that one. So any of these inequalities we do, if they ever happen to put X on the right hand side, it will eventually turn around and put X back on the left hand side, just to make things work out. So. All right, so we've got 8x minus 15 less than 73. Just like a regular solving equation, we're going to add 15 to both sides. So we got 8x less than 88. Divide those two out, so then we got x is less than 11. Okay, so solving it, got it there. Graphing it, okay, so we got 10, 11, 12. And again, as long as the x is first, you always tells you which way to go. You've got to have this arrow basically graphing that side. And when you get to 11, it's going to be an open circle. Okay, interval notation wise. Again, we just abbreviate for IN for interval notation just to make it shorter. That's where you're basically just telling me, all right, what did we graph on the graph here? It's going all the way to the left, so that's negative infinity. When you get to 11, it's going to stop there, so it's going to be a parentheses with negative 11 in, from negative infinity to 11. All right, so for example 2, same thing, just making it a little bit tougher, a little longer. So go negative 3 times 2x minus 5 plus 1 less than or equal to 4. Okay, so the very first thing is go ahead and distribute out the negative 3. So we've got negative 6x plus 15. Okay, and then from there, you've got on the left-hand side of the inequality sign, you've got the 15 plus 1. Just go ahead and make that part out to be 16. And then we can subtract 16 off both sides. So negative 6x would be less than or equal to negative 12. Okay. And then here's the one thing you've got to remember with inequalities. At the end, if you get to the end of this thing and your last step is that you're going to go back and you're going to divide everything through by -6, that when you divide by a negative number or if you multiply by a negative number, so if you multiply or divide, now here's the key thing: it's got to be both sides. So if you multiply or divide both sides by a negative number, you've got to flip the inequality sign. So you've got to change your inequality sign. Because, at this point, we're looking at talking about the negatives. When we divide both sides by a negative, now we've got x, and now we're talking about the positive. So if you think about where the number line is, everything negative is over. If the pencils are, if we go ahead and do the number line here underneath it, if we've got 0 in the middle, because right now we're graphing everything on this side that's negative. When we divide or multiply through by negative, now instead of talking about the negatives, now we're talking about the positives. So instead of talking about everything over here, now we're talking about everything over there. So that's why you got to kind of flip your inequality sign around, because you flip which side of the graph it is you're talking about. So now you got to flip this way the sign goes for this thing. So for that one, instead of being less than or equal to, now we're talking about that being greater than or equal to. Okay, so when we go to graph this one, this time we need a solid circle at 2. And now it's everything hit it off this way. So if we talk about it in an inequality form, or sorry, interval notation form, that starts at 2 and then goes to infinity. Okay, and other than that, you don't have to worry about changing any inequality signs. Adding, subtracting, you never do it. Even back up here, we did distributed property with -3, but it was only on this side, so we didn't have to worry about flipping that inequality sign. Basically, once you do the first couple of steps, once you've done distributed property and you've added and subtracted everything you can do, which usually multiplication division is going to be like the last thing you do. But basically, if you get here and that x, the number with the x is negative, and you multiply and divide, that's when you got to flip that sign. Add and subtracting, you don't worry about it. It's only that last step when you either multiply or divide by a negative number. Okay. All right. Now, if you happen to get a decimal, let's just give you one real quick. We'll make it really short, really easy. Let's say you've got 8x less than 4. If you happen to get a decimal, more than likely, Math Excel is either going to give you multiple choice or they'll make it so that the numbers are easier to see. So for this one, if we were solving it, we divide both sides by 8. So x is greater than 4/8. You can divide both of these by 4 just to simplify the fraction. So you got x is greater than a half. Either one of two things is going to happen. Either they'll give you, for Math Excel, either be multiple choice and you just pick the right graph and you'll have it there, or they'll actually have a half mark in between a lot of times, where you'll have like 0, 1, and then halfway in between they'll actually give you a mark where you can do that one. So it'll either be multiple choice where they mark it like that, or they'll actually give you a option where you've got this point that's in between. The biggest thing is that point's got to be between 0 and 1. They shouldn't give you one where like one's a half and one's a third. That won't be an option. Probably what you would have is you'd have one that would be like this one's going off to the right here. So that one's going this way. You'd have one that would be correct this way. You'd have one that would be wrong going this way. And instead of being a half, they probably would have one at 2, because a lot of times people look at that and they'll go, oh, it's 8 and 4, answer's got to be 2. Well, If it was 4x and 8, yes. But if it's 8x and 4, instead of being 2, then we got to have a half of that. Okay, so graph-wise, that one, you'll just put something in between 0 and 1. If it was 2.6, you'd put something between 2 and 3. They might possibly give you like a little half mark so you can graph it. But it should be kind of easy to see what's going on with that one. Interval notation, same way that for this one, you're starting at a half and going to infinity. So they'll either let you put 1/2, they might possibly let you put the 0.5. And just like hopefully everybody's kind of noticing now that if they do that, they'll tell you either write it as a decimal or write it as a fraction. They usually give you directions on how they want those answers when they go through this thing. Okay. All right. Now, we talked about these a little bit when we were doing the interval notation last time, but let's make sure we've got it here. The trick questions, I guess. It's either always or never true. That they talk about something being always true with the graphs, that's basically their way of saying infinitely many solutions. Because everybody's got their own little version of how they say that. Some people, we've been used to, probably most everybody's in here, infinitely many solutions for a while. Sometimes they start changing that to being always true. For that one, if you're going through with one like that, you still solve the inequality. And the variables, or the variable, probably in this case, and the variable will not be in the answer. And then if the inequality is true, so let's say you're working this thing out and you get to the end and you wind up with like 0 is less than 8. Well, 0 is always less than 8, on the number line. It could be that you get like -10 is greater than or equal to -20. Again, always true. Okay. This one sometimes gets people. 5 is less than or equal to 5. And they're like, well, 5 is not always less than. No, but 5 is always equal to 5. So as long as it fits into either one of those two categories, it's okay. So as long as if you solve this thing out and you get an inequality that's true, 0 is less than 8, -10 is greater than or equal to 20. You get something, you look at it and go, well, yeah, that's true. Then it's going to be always true. So and they kind of do that instead of saying infinitely many solutions. They kind of use a new wording there where they talk about something being always true. But just realize that always true basically is the same thing as saying it's infinitely many solutions. They kind of a little bit of a new vocabulary, but just kind of a different way of saying it there. Okay, your graph on that one is basically it's the entire number line. And you're going to shade in the whole entire number line. So that's one where they should just kind of do something like this. Okay. And then interval notation, if it's infinitely many solutions or all real numbers or always true, whatever it is, interval notation, that's going to be negative infinity to infinity because it goes forever to the left, it goes forever to the right. So that would be your answer in interval notation. Okay. So there, and again, we kind of looked at that a little bit. Just make sure we go back and get that one. So if it's infinitely many solutions, it's always true. And again, that's where you're going to work a problem out, and eventually everything just kind of goes away, variable wise. I think we kind of had gone over that one. Just remember, if you were doing an equation like that, just kind of give an example of one. That would be where you had, 2x plus 3 is less than, 2x plus 7. That as soon as you subtract the 2x, and remember, some people will put 0x and then they'll come back and just put an x here. I'm like, no, no. Remember, if you do 0 times x, that's just 0. So that's 0 plus 3. Same thing there. If it's 2x minus 2x, that's 0x. If you do 0 times x, that's still just 0. So that would leave you with 3 is less than 7. And 3 is less than 7 all the time. So that would be one where, you'd go back and graph the entire thing and tell me it's always negative infinity to infinity. Any number you plug in will always make that thing true, no matter what it is. Okay. So there's that process you would go through that eventually at some point in time you're going to move the x's to one side, and when you do that you're going to cancel out the other ones so that all the x's are just gone. And just remember that if you have a 0x, it's not x, you're still doing 0 times x, so that number is still going to be 0. That sometimes, the first time back in, sometimes with 0x, like, oh, that's just x. No, remember, if you've got x, technically that's 1x when you do that. So, question. The graph on that one basically would be, now that's probably one where more than likely it's going to be a multiple choice for a graph like that, because your graph would be the whole entire number line like this shaded in. And I don't know that you can do that with Math Excel. So more than likely in that case, that's going to be the graph on that one would probably more than likely be a multiple choice kind of thing, because I can't think of a way they make you graph that one. So yeah, some way or another, your graph would look like that where the whole thing is shaded in. Okay, so on the flip side of that one, we got what they call never true, which is basically the same thing as no solution. Yeah, and this one's just the opposite of what we were doing for the always true. You're going to solve this one. You're going to solve the inequality. Uh, with no variables in your answer. And when you finish this thing, you've solved out, and the inequality is false. And that's when it's going to be never true. Which, again, really, if it's never true, that's the same thing as saying that it's no solution to this thing. No matter what number you plug into this thing, it's never, ever going to work when you come off that. So it'd be one where you've got 4 times x minus 3 on one side, and maybe on the other side we've got 4x plus 6. And maybe it's 4x minus 3 is greater than 4x plus 6. Or if you did just a little bit of distributed property, you got 4x minus 12. Okay, and it's set up the exact same way that when you start to move your variables from one side to the other, they're all gone. So when you subtract the 4x from this side, so you knock this out, so it's gone, it's basically 0. You would do the same thing over here. Well, that knocks that out to make that one also 0. You're left with negative 12 is greater than 6, which, that was where we were like, okay, negative 12 is not greater than 6. Positive 12, yeah. Negative 12, no. This thing is false. So if that thing was false, then basically they would say it's no solution, or sometimes in that case they would say that it's never true. Okay. And graph-wise on this one, it's an empty graph. And probably in a lot of these cases, they won't even ask you to graph this one because it doesn't make sense because there is no graph. That you've just got this basically, you've got this empty number line and there's no graph on it. So that was one where they probably would not even ask you to graph something like that because it just doesn't make any sense because there's nothing there. Same thing with interval notation. There's nothing there because there's no answer to it. So interval notation, they wouldn't ask you to do that because there's nothing there. It's blank. It's empty. It's an empty set when it comes to that thing. Okay, and then the last couple of things that kind of fits in with this part where we're graphing inequalities is we're doing the compound inequalities. And again, same thing. We kind of looked at this back with interval notation, but we didn't really spend a whole lot of time on it. So we're kind of backing up here and going back and picking up on it. All right, and there's basically two different types of inequalities that we're looking at. You have the ands, and you have an or. And we'll do the and first on this one. So we got 2x plus 14 is greater than negative 12. And 9x is less than 18. Okay, and with the and statements, the solving is still the same. You just solve this equation. You solve that equation. And once we get finished with it, we'll go ahead and do those two pieces here. So for this one, we're going to subtract 14 from both sides. So we've got 2x is greater than negative 26. Divide both sides. Now, in this case, you're dividing by a positive 2 because you're going to divide by 2 to cancel this out. Since that's positive, you don't flip your inequality signs. So that's x is greater than negative 13. Okay, one on the right side, really easy. Just divide both sides by 9. And it's positive, so that makes it x is less than 2. Okay, and with the and, I always kind of like doing it this way. If it's an and statement, I think in the textbook they technically say this is the overlap of the two graphs. I kind of like to make it easy. If it's an and statement, you're going to sandwich it between the two numbers. Because you got the and in the middle of it, right? So and goes with sandwich. So you're going to sandwich this graph between those two numbers. That negative 13 is the low end of it, and 2 is going to be the high end of it. So you're going to sandwich it between the two numbers. So this x is going to be stuck between negative 13 and 2. And to get this one, we're just going to, because we've got the x's first, well, now we're going to put the negative 13 first. So if you do that, this arrow still points at the 13. The alligator is still going to eat the x just because we flip it around. Still going to go the same way. So now x is sandwiched between negative 13 and 2. Okay, so whenever you see that and statement, just realize that the and means you sandwich it between those two numbers. That's the low and the high end of it when you saw those two things there. Technically, they call it the overlap, but you know, it's sandwiched between the two numbers. When you graph this thing, really you just need those two numbers. You need the negative 13 and the 2. Both of them are open circles. And then it should just be everything between those two things. It looks like a sandwich, right? There you go. Got the bun on top. There's the ketchup in the middle on your sandwich. Okay. Interval notation, exact same way. You start at negative 13. You stop at 2. And there's your interval notation. Again, it looks like it's an ordered pair, but again, if they talk about interval notation, we know we're not talking about an ordered pair. It's the starting and the stopping point of whatever it is that your graph wise that you're looking at. So and statements, just realize it's always going to be sandwiched between two numbers. Okay. The or statements. Let's do 4 times x plus 3 less than or equal to 16, or negative 12x is less than negative 144. Sorry, can you see that? Okay, and same thing with the and statements. Just forget about the one. If you solve one, forget about the other one. We're going to solve this one. Then we're going to solve this one. And then when we get to the end, we're going to put those two things together. So first thing is we got distributed property. So that's 4x plus 12 less than or equal to 16. We'll subtract 12. So we got 4x less than or equal to 4. So it's x less than or equal to 1. All right. And then for the second part, all right, with the or part, we're going to divide both sides by negative 12. So it makes it x. And again, because it's dividing both of them by negative, I'm going to flip that around from being a less than to a greater than 12. And for the or and was basically the overlap of the two graphs. When you talk about the or part of it, it's anything covered by either graph. So for the or, you just graph those two things, and whatever you get, that's what you get. You don't have to worry about the overlap or the sandwich or anything with that one. So kind of do the same thing. We started at 1 and 12. This one's less than or equal to 1, so we need a solid circle there at 1. Going that way. We got an open circle at 12 going that way. Okay, and that would be your graph. So you've got the left side over here, and you've got the right side over here. Okay, so if the and was a sandwich because you had the and in it, the or graph looks like oars on a boat. Get it? Because it's an or statement, so we got ors on the boat. Yeah. So that's why I always kind of think about it is here's your boat, this is the bottom of the boat here. There's your oars out on the side, and you're getting ready to get in and start paddling away. So or statements, it usually looks like oars on the boat. You got one on the left and one on the right, and you've got the empty spot in the middle where you'll be sitting. So here you are in the boat. You got some really long arms going out over here to the oars. Okay, now interval notation. It's going to be the two-part interval notation we were talking about. And there you go. There's my fabulous artwork, by the way. I'll get rid of that. When you do interval notation, this part of it, you're going from negative infinity up to 1 with a solid circle. So we're going to make it a square bracket. And then we're going from there, and we're going to jump from 12 to infinity, open circle there. So that's a parentheses here. And whenever you've got the or statements, just put a U in the middle of it. Looks kind of like the U part of the boat. It says, all right, we're going to go do this part, and then we're going to jump over here with that U for a union with this part over here. Okay. All right, now with the ands and the ors, sometimes you have some trick questions on those. Let me just show you one of those. Because you may get one like this where you got x is greater than 1 or x is less than or equal to 6. But if you go graph this one, we graph what's on the left. We've got everything greater than 1 going that way. But then if you graph this one, you've got everything is less than or equal to 6, which is a solid circle here at 6 going that way. Which means if you do that one, you've covered everything in every direction. So that would actually kind of be a trick question because this would be one of those where it's going to be always true. Because you've covered the entire graph. So give me a number that's greater than 1 or less than 6. Well, every number is either greater than 1 or less than 6. Doesn't matter what number you pick. So it's always going to be true for that thing. This one up here, you've got this gap. If we're picking numbers less than 1 but greater than 12, well, we've got to leave out this gap between 1 and 12 because 2 doesn't fit here and it doesn't fit here. So that's why we've got this gap in here. If you happen to solve an equation and you get down to the end and you get one like this and you graph it and you go, well, I covered everything. Well, if you're doing 4 is greater than 1, so it fits here. If you're like, well, let me pick a number that's less than 6, I can do negative 10. Well, that fits here. So no matter what you do, it's always going to fit into that category. So something's always going to be on the graph somewhere. That there's no gap. You can't tell me a number that's not less than 1 or greater than 6. Or greater than 1 or less than 6. There's always going to be some number that'll fit there. All right. And again, if they were going interval notation here, that would be negative infinity to infinity. Okay. And then the one other one that we've got that's just an extension of the and that you're going to work with. Maybe something like this. Where you got negative 12 is less than or equal to 4x plus 3 less than 16. Okay, so this is where they've taken an and statement that we had back here, but they've gone ahead and just made it one big giant problem. So if you've got it set up like this is basically just like an and statement because negative 12 is less than 4x plus 3. And at the same time, 4x plus 3 is less than or equal to 16. So that's basically just an and statement where they put the two things together in one. And if you have to solve this one, basically you always kind of work from the middle out. So the very first thing here is that you would wind up taking and go ahead and do a distributive property in the middle. Make that 4x plus 12. Okay. And for these, again, you're always working from the middle out. So if you're going to like solve this part, if we'll cover this up for a minute, how you would subtract 12 here to solve this part of the inequality, you've also got to solve this one at exactly the same time. So if you subtract 12 here, then you got to turn around and subtract 12 there. So this one, you're going to do it in all three parts. Whatever you do in the middle to get this x by itself, you're going to do it to the left, to the right, and the middle. So you're doing all three parts basically at the same time. So that would leave you with a negative 24 less than equal to 4x less than equal to 0. Oh, it was 16. My bad. Okay. Thank you for catching that. See, if I was one of those teachers, I'd go, y'all are paying attention. See, I was waiting for you to catch that mistake. No, I just messed up. Yeah. I always hate those teachers like that. I'm like, you didn't do that. Like, you just messed up. Just admit it. Okay, so 16 minus 12 will get you 4. And then your one last step at the end, you're going to divide this by 4. So you're going to divide every single piece of it by 4. So you get negative 6 less than equal to x less than equal to 1. Okay, so x is sandwiched between negative 6 and 1. So on your number line, same thing. It'd be negative 6 to 1. And you're going to sandwich it in between those two numbers. You just got to make sure that whatever these things should be circle-wise, solid circle here, and again, it's just everything in between those two numbers. Okay, so there's your graph, and your interval notation is going to look basically the same thing. So going from negative 6 to 1, and then square brackets on those.